Hey guys, today we're going to look at the topic 16 probability test to review for the retake. So hopefully you can get into Horizon and see which questions you missed so that you can focus more on those. But question 1 looked like this. Mark had a basket of 40 yellow tennis balls and 35 white. What's the probability that the next tennis ball he chooses will be yellow? So we're looking for the probability of getting yellow, which means we need a fraction. There are 40 yellow out of the total amount of tennis balls. You got to add those together to get 75. And then you have to look at both of these numbers as, oh, I got to simplify. So if we divide 40 by 5, we get 8. And if we divide 75 by 5, we get 15. And that is our simplified probability as a fraction. All right, let's look at number 2. Beth will reach into the bag and randomly choose one balloon. What's the probability she will choose a green balloon? So we got to find the green, which is 22, out of the total. So if we add all of these up, including the green, we're going to get 55 total. And that simplifies to 2/5. Divide them both by 11. If you weren't good at simplifying, you could also make this a decimal. So you could do 22 divided by 55 on your calculator, and that gives you 0.4. Because this is a multiple choice test, you can see which one of these also equals 0.4 when you divide them. There was a lot of simplifying on this test. Question 3 was the dartboard. So a dart is thrown and it lands on one of the small rectangles. What's the probability of getting a D? So 1, 2, out of 4, 8, 12, 16 total. Divide the top and the bottom by 2 to get 1/8. Okay, what's number 4? Peter picks one bill at a time from a bag and replaces it. He repeats this process 100 times, records the results. So he got a $1 28 times out of 100. He got a $5 14 times out of 100. And then a 56 times out of 100 and 2 out of 100. So we want to know which one of those probabilities is simplified to 7 over 25. So which one of those probabilities simplifies to 7 over 25? There's a lot of different ways to do this. We could find the missing number, or if you noticed that this is just 25 times 4, then it's the same on the top, which would be 28. So the dollar bill is the one that happened 7/25. Like those two fractions are equivalent to each other. Pilar has a square game with 25 equal sections. The sections are randomly colored 4 different colors. Each player has a chip. What's the probability of getting yellow? So there are 10 yellow out of 25 total sections. Divide the top and bottom by 5 to get 2/5. Oh, I got to turn that into a decimal. So I'm going to do 2 divided by 5 on my calculator. And then I'm going to multiply that times 100 to get 40%. Okay, question 6. All right, this one looked really weird online, I know, but this was supposed to always be the theoretical, and this second one was the experimental chart. And we were trying to figure out which one was correct out of these 4 options. So if there's 6 chocolate, 3 vanilla, 4 shortbread, and 7 peanut butter into a bag, that's the theoretical. That would be the theoretical chance he would have to get chocolate, vanilla, shortbread, and peanut butter. So I'm going to say that this one so far could be good, but B cannot be. This is the theoretical, this was the experimental, and that is not the correct numbers, right? 6, 3, 4, 7. Neither is C. This is the theoretical, this is the experimental. But D looks okay, 6, 3, 4, 7. Okay, so now that the theoretical is taken care of, let's look at the experimental. He reaches into a bag 20 times. He chooses 7 times chocolate, vanilla 1, shortbread 2, and peanut butter 10. So now my numbers need to be 7, 1, 2, 10. Nope. That's the experimental probability. So the correct answer was D. These numbers match the theoretical. These numbers match the experimental. Question 7. Sean tossed a fair coin 20 times. These were his results. He thought that the probability of tossing a head was the same as tossing tails, and therefore he should have flipped heads. Which statement below I think is true? Sean must have tossed the coin wrong. No, that's not what happens when you do an experiment. Sean was conducting an experiment. The experimental probability will not always match the theoretical. The probability of tossing a head is not the same. Yep, you have the same probability. 1 out of 2 if it's a fair coin. He needs to flip the coin 4 more times. We don't know that that's going to happen. You have a 50-50 chance every time of flipping a coin. So that one was B. Question 8. If a student flips the coin 10 times and gets 7 heads and 3 tails, but then they flip it 1,000 times. 1,000 times is a lot, and you're going to get closer and closer to the theoretical probability of getting heads or tails is really 1/2. You have a 1 out of 2 chance of getting heads every time you flip the coin. So that's a fair shot for both of them. So that's why it's 50-50. It basically, we're kind of ignoring these results right here, because this is theoretical. So we're really going off the theoretical probability for this one, 500, 500. A number cube is rolled 12 times in a game. The chart shows what number was rolled on each turn. But if the cube is rolled 1,000 times, what is most likely? Most likely, it means theoretical. We don't even really need these results again. What would most likely happen if you rolled the dice 1,000 times? Each number's going to be about the same. We can't base it 4 rolls and 6 rolls would be equal. No, there's never going to be a 2. Well, of course you're going to roll a 2 if you roll the dice 1,000 times. So basically, you're ignoring the experimental probability again. All right, last question. This spinner has 6 sections. This arrow of this spinner was spun 60 times. On 45 out of the 60 times, the arrow landed on the section labeled with a multiple of 4. What was the experimental probability of landing on a multiple of 4? Well, they told us right here that it's 45 out of 60. And then we're going to simplify by dividing the top and bottom by 5, I think will work. So 45 divided by 5 is 9. And 60 divided by 5 is 12. Oh, I can divide again. Sorry. Could have divided by 15, right? 9 divided by 3 is 3. 12 divided by 3 is 4. So this one is 45 out of 60. We're experimental. If we were looking at theoretical, if this word was theoretical, we would have done 4 out of 6. But this one was experimental, so we're looking at the numbers from the data. All right, guys, hope that helped. If not, let me know if you have any more questions before you take the retake. Thank you.